All right, so now we're going to calculate probability statements using the standard normal probability tables that are in the back of your packet. So let's return to the example 1. So again, we have the average height of CGS freshman is 60 inches with a standard deviation of 3 inches. Okay, sketch and shade the normal curve, calculate the z-score, and then find the probability below. So we want to calculate the probability that a randomly selected CGS freshman is less than 58 inches tall. And that is represented by this symbol, these symbols right here. That means that refers to the probability that a observed value x is less than or equal to 58 inches tall. Okay. I guess technically it should be strictly less than, but with these sorts of examples, with probabilities in the normal distribution, it doesn't make a difference. The number ends up being the same either way. Okay. Well, the key is, if we want to use these tables, we need to find the z-score. So we take the z-score of 58. Okay, so we take the z-score of 58, which I believe we already calculated, x minus mu over sigma, and that came out to be negative 1.33 approximately. Okay, so on our standard normal, or else let's make this the other one. So our mean is 60, so 58 is around, let's see here, almost a full standard deviation less than, so maybe around here. So that's where 58 is, not quite a full standard deviation less. And we're asking, what is this probability to the left of that? So in other words, what is the area of that red part? All right, so let's go to our tables, and we're going to find negative 1.33 on the table. So what's important to notice here, first of all, is that when you find a z-score on this table, and we'll show you how to do that in a second, the number that we get in the table tells us the area to the left of that z-score. That's what we want in our problem that we're finding. Okay, we're finding the left tail. That's called the left tail. These always give you the area to the left on the standard normal curve. So let's find negative 1.33. So the first thing you do is you look at this column, and we go down until we find negative 1.3, but we're not done yet. Okay, so maybe we'll just keep going down here, and then we go in, and then we go up here. We also find the hundredths place, which is right here. So we go down this column and across this row, and we circle. This is the number that gives us the left tail of z equals negative 1.33. That's 0.0918. So going back up here, this is 0.0918. Very rather small there. In other words, in terms of percentages, that is 9. Again, to go from this kind of number to a percentage, you multiply by 100, so about 9.18% chance. Okay. Continuing on, what is the probability that a randomly selected CGS freshman is more than 58 inches tall? All right. So now, if there's our 60, there's 58, we're asking, what's this area? Well, We can convert it to a z-score. That's all well and good if you want. That should be a 58. Make that a little bit better. Okay, and this is just the probability. 58 is the same, so it's still the same z-score. But if you go to the probability table, the only number you're going to find is 0.0918. And that can't be right because that's we're asking a different question. What's the probability that a randomly selected CGS freshman is more than 58 inches tall? So that's a right tail question. Okay, this is a right tail. And the table only gives you left tails. Well, we can deal with this problem, but we can't just use the table, okay? Here's the key. The left tail plus the right tail together give you the entire curve, which has probability 1. The whole area is 1. So, because they add up to 1, the probability of the right tail is 1 minus the probability of the left tail, which gives z less than or equal to negative 1.33. Okay, those are the same thing. So we can do 1 minus 0.0918, which is 0.9082, or a 90.82% chance. Okay, so that's how you deal with right tails. All right, let's do one more. What's the probability the randomly selected CGS freshman is less than 60.15 inches tall? All right, I want you to do this one on your own. Keep in mind we've already found the z-score for this one. Okay? All right, so we're finding the probability that x is less than or equal to, but I'll be a little more careful this time. I mean, I'll use strictly less than, but again, it doesn't matter in this situation. It doesn't make a difference. What is the probability that x is less than 60.15? Okay, convert to a z-score. We've done that already. You can look on the previous page. That is z less than, and the z-score is 0.05. So then we go to, and then, it's it's just to the right of the mean is what we're looking at. And we're looking at that whole tail, the left tail. Because it's a left tail problem, we can go to our z table. Now the first page has all negative z values, so we need to go past that to the second one. It gives us positive z values. And we go to the first row, and we stop here at 0.5. So it's that number, 0.5199. Not a point there. Or 51.99%. Okay. Go ahead and pause and do part D. All right, and you should get 0.8944 for that one. Okay, part E. What is the probability that a randomly selected CGS freshman is between 56.25 and 60.15 inches tall? How do we find that? Well, this is a compound statement. All right. So in symbols, what we mean is this right here: probability that the observed value is greater than or equal to 56.25 and less than or equal to 60.15. So you write it this way as a compound inequality: 56.25 less than or equal to x less than or equal to 60.15. The picture here, okay, again, the mean is 60. So we're looking, 60.15 is just to the right. 56.25 is about here. So the area between them, that's what we're trying to find. Now, how do we calculate these kinds of probabilities? Well, here's what you can do. You can think of this region as being, well, what if we took everything, the whole tail, from 60.15? What if we calculated that left tail, and we can use a table to find that, and then we subtracted the tail from 56.25, that would leave us with the blue region, the what part that we want. So in other words, this is the same thing as the probability that x is less than or equal to 60.15 minus the probability that 56.25 is less than or equal to x. Sorry. Let me correct myself. Probability that x is less than or equal to 56.25. These are both left tails. This is a left tail, and the red curve is a left tail. The red one is less than or equal to 56.25. All right. So now we can find these using z-scores, and we've done this already. Z less than or equal to 0.05 minus z less than or equal to, so let me see here, the z here is negative 1.25, and these probabilities were 0.5199 minus 0.1056. All right. So if I said that, I can't remember if I said it or not, if I said that this was a left tail problem, that's incorrect. Part D was a right tail problem. At least 56.25 is this kind of problem. All right, so we get this number from taking the left tail right there. Okay, so this number is 1 minus 0.8944. When you subtract that, you get 0.1056. All right, so in the end, we get an answer of 0.4143. All right, and last but not least, please do part F and G. All right, so part F here, you should get a very small number, 0.0004 or 0.04%. And for part G, okay, how do you find which one is taller relative to their class? You're comparing z-scores. So we take the z-score of the freshman, who is 62.55 inches, and we compare that to the z-score of the sophomore, who is 65.6 inches tall. And we compare them. Well, for the freshman, okay, we use the mean of 60.55 minus 60 over standard deviation of, I believe that's 3. Whereas for the sophomores, we do 65.6 minus 62 divided by a standard deviation of 2. And the two z-scores that we get are 0.85, and over here we get 1.8. So which one is taller relative to their class? It's the sophomore. is taller. All right.